Hello everyone to this lecture about the most known probability distributions. We will start about the Bernoulli distribution. So we say that a random variable or a discrete random variable x is Bernoulli random variable if its PMF is defined by p of 0 equals 1 minus p and p of 1 equals p. If p is the value of the probability. For example, if we flip a coin, we will get the results head and tail, and we can define the random variable x that takes 0 if it is a head and 1 if the result is a tail. So the probability of 0 means the probability that we get head is equals, if p is equals 1/2, so it will be 1/2, and the probability of 1 is equals 1/2. So this is the Bernoulli distribution, and its PMF is represented by that. So we have 0 here, and we have 1, and we have 1/2 as the value of the probability, 1/2. So this will be the PMF of this distribution. So 1 and 0, here is x, and it is 0 otherwise. The second distribution we ask today is the binomial distribution. So we say that discrete random variable x is a binomial random variable with parameter and p if x represents the number of successes that occur in n independent trials. For example, if we have n equals 4, we flip, for example, a coin 4 times, and we set the success as when we get head, the number of heads that we get, and failure for the number of times we get tails. So in this case, we have head as the success and tails as the failure, and it is a binomial random variable. And the PMF of a binomial random variable is given by this expression, and the probability of getting I heads here, I numbers of heads here is, let me compute it here in this space. So P of getting 0 heads is equals 4, because you have 4 and equals 4, so 4 experience chosen 0 times the p here. When we consider that the p here is 1/2, so it is a fair coin, call it a fair coin when the probability of getting head and tails is 1/2 for each trial. So p here will be equals 1/2 power 0 times 1 minus p here is 1 minus 1/2 times n minus I here is 4 minus 0, so it is 4. 4 chosen 0 is 1, so 1 times 1 over 1/2 power 0 is times 1, and here is 1/2 times 4, it is 1 over 16. So final result is 1 over 16 for 0. The probability of getting 1 is equals 4 chosen 1 times 1/2 power 1 times 1 minus 1/2, which is 1/2 power 4 minus 1 is 3, which is equals 4 chosen 1 is 4 times 3 times 2 times 1 over 1 times n minus 1, it is 3 times 2. So this is times 1/2, because 1/2 power 1 times 1/2 power 3 is 1 over 8. So this will cancel with this 2 also. We will get 4 over 16. And the probability of getting 2 heads is equals 4 chosen 2 times 1/2 squared times 1 half, also 4 minus 2 is 2, so it is 2 here, and here will be 4 times 3 times 2 over here will be 2 times 2 factorial times 4 minus 2 is 2, also 2 factorial. We can cancel this 2 times 2 with this 4. This also times here 1 half square is 1 over 4 times 1 half square also is 1 over 4. So we'll get 3 times 2 is 6 over 16. And here for the P of 3, we'll compute P of 3 and P of 4. P is equals 4 chosen 3, it is 4 by 3 by 2 over 3 times 3 factorial, which is 3 times 2 times 4 minus 3, it is 1 factorial, so it is 1. So this 3 times 2 will cancel. This times 1 over 2 power 3 is 1 over 8 times 1 half, because it is here 4 minus 3 is 1, so 1 half power 1, so it is equals 4 over 16. And the P of 4 is 4 chosen 4, it is 1, so because it is 4 here and 4 here, so it is 1, times 1 half power 4, it is 1 over 16, and times here will be 1 half power 0, because 4 minus 4 it is 0, so it will be 1, and we'll have 1 over 16. And we can check that the sum of all this PMF is equals 1. So we have here 1 plus 4 plus 6 is 11, plus 4 is 15, plus 1 is 16, so 16 over 16 is equals 1. We can represent the PMF here, so we can represent the PMF that we have 0, 1, 2, 3, 4, and the value are 1 over 16, 2, 3, 4, 5, and 6. 0, 1, 2, 3, 4, 1 over 16. We don't have 2, so 3. We don't have also 3. 4 over 16, and 5 don't have 5, and 6 over 16. Value of 0 is 1 over 16 is here. Value of 1 is 4 over 16. Value of 2 is 6 over 16. I'm sorry for my drawing. And the value of 3 is 4 over 16. The value of 4 is 1 over 16, and so on. We have also in this lecture the geometric distribution. So if we have n independent trials are performed until a success occurs, and each of these trials have a probability of success p, so in this case we call this geometric distribution, and its PMF is defined by 1 minus p power n minus 1 times p. For example, if we flip a coin till we get the success, so that means that we have tail till we get head at the n, so here all these are tails till we get the head at the n time. So in this case we talk about geometric distribution, and its PMF is defined by this expression. The Poisson distribution is also very known distribution in probability, and it is defined with its parameter lambda, and usually it is given, and has this PMF of e minus lambda I over e factorial. If we have, for example, a book and we want to know the probability of having I numbers of error typing. So in this case, we will use the Poisson distribution. For example, if we have a book and we want to compute the probability that it has just one error, so it will be equals E minus lambda times lambda power 1 over 1 factorial. If lambda is given as lambda equals 1, for example, so this P of 1 is E minus 1 times 1, so it is E minus 1. If we have a big number here, so this will be difficult to compute this PMF. So usually it is easy to compute the P0 of probability and then compute the others by like that. So for example, P of I plus 1 is equals E minus lambda times lambda power E plus 1 over E plus 1 factorial. If we divide it by Pi, this will be divided also by Pi is E minus lambda times lambda power I over I factorial. So this will be equals this E minus lambda and E minus lambda will cancel, and lambda power I plus 1 and lambda power I will be cancelled this I, and we will get just lambda divided by I plus 1 factorial, and I factorial will be also cancelled, and we will get just I plus 1. So this is the easiest way to get to compute the value of. So in this example here, it will be easy for us to compute P of 2, because when we divide it by P of 1, we will get this expression. So lambda is 1 divided by I here, I is 2, so 2 plus 1 is 3, so we'll get 3. So that means that P of 2 is 1 over 3 times P1 is E minus 1, so E minus 1, and so on. We have also the uniform distribution, which is one of the most known distribution in probability or in discrete probability. So the discrete random variable in the uniform distribution will take integers values in a finite interval or range a, b. So here we just take the integers in this interval with equal probability, and its PMF is defined by this expression, where here 1 over b, which is the maximum value here, minus a plus 1. For example, if we have an interval of 0 and 5, for example, so P of k here will be equals 1 over b here is 5 minus a is 0, so 0 plus 1, so minus 0 plus 1, which is 1 over 6, and we can represent it like that. So we have values from 0, 1, 0, 1, 2, 3, 4, 5, 6. Here is x. So here is px of k. So all the values are the same, 1 over 6, 1 over 6. All of them are the same, equal.